Hello there. Hi everyone. Hi June. This is the experiment we had planned on doing Saturday, and I'm continuing the analysis till on Sunday. So this is Sunday, I forgot the date, the 14th, I guess. Yes, so Sunday the 14th. And just because I'm all by myself, I thought I'll record and I'll show you the way I approached this experiment. So the the aim of this experiment is to find out if we can induce senescence in HK2 cell lines using etoposide. And I apologize, there is a lot of background noise. I'm sitting on a flow site computer, and no one around me, but there is a lot of background noise coming from the freezers. So let's hope I can record the way I analyze the data. So the experiment is pretty simple. Jun took HK2 cells, and she plated them and then induced etoposide, and 48 hours later we look at if is the beta gal increased. So last time we took the conventional beta gal and we found that HK2 cells express beta gal, so the conventional beta gal won't work. So the question was, okay, if we take fluorescent beta gal and if we induce the HK2 cells with etoposide, does the fluorescence of beta gal go up, and can we use HK2 cells then to do a dose response curve? So this was a start experiment. We didn't know what doses to start with. So Xiaojun just took 10, 20 and 40 of etoposide doses, and I she then added for fluorescent beta gal, and then I took over and I treated the cells, and I did the flow experiment on Saturday the 13th of January. So here is the analysis part of it. So if you look at overall, you kind of are disappointed that there is no major change, but then I started really teasing down onto what are good cells versus what are bad cells, and these are some of the observations I have. Let's take them one by one. So here, these are the control HK2 cells, and we start gating on the focus. These are all cells gated on the focus, and then we go to the focus, and then these are the single cells, and there is a lot of other things. Not that these are not single cells, but here the single cells give me a nice sweet cluster. So I'll stay with that cluster, and uh, after the cluster, this is how the cells look like. They look cute. They are DAPI negative, so that means they are live cells, and then they are beta gal positive. I have not fixed them, so they shouldn't have DAPI. Of course, if you add a lot of DAPI, all cells will, no matter what, stain with DAPI. Like for example, you see here there are a lot of cells stained with DAPI. So primarily these cells are stained with DAPI and beta gal, and then we did compensation using single stain controls for both, and then I'm analyzing the data. So as you can see, all cells focus, and then I go to single cells, and then I see lots of single cells, and then I take this cluster and gate it on DAPI versus fluorescent beta gal. Ignore this part of it for now, but I'm let's focus on this part. Let's focus on what we see here. So the these cells, HK2 cells, express beta gal natively, and if I gate on those, you can see that the beta gal, I have sort of decreased the fluorescence, but they have some expression of beta gal natively, and it's clearly a good expression. So for some reason they express beta gal at a native stage. Are they senescent? I don't know, but they have expression of beta gal. Now they have a little bit of R1 is the gate, so this will show me that the expression has gone up. As the expression goes up, the 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 cell should move to the right. So I created a one quadrant here called as R1, which is e to the 4 to the e to the 5, and then R2 as e to the 5 and e to the 6. For now, let's ignore the DAPI negative beta gal positive. So I created these two quadrants. So any increase that is coming from etoposide should be seen in either R1 or R2 quadrant. And I repeat, any increase in etoposide should come from R1 or should be seen in the R1 and the R2 quadrant. And let's start here. So around 87% of cells are in the R1 in the native quadrant, and around 10% of the cells are in the R1 quadrant. So this sort of matches with our in vivo data, where around 5 to 10% cells are senescent. So now let's take a look at if we run this data at a doses of 10, 20, um, uh, 10 10 nanomoles probably of etoposide, 20 nanomoles and 40 nanomoles of etoposide, what